Hi everyone, thank you so much for joining this session today. It is delightful to be back here in Sweden. This is my third time speaking at Jfokus, which was actually the first conference I ever spoke at, so it's got a special place in my heart and it's great to be joining you guys again. So if anyone who hasn't come to previous editions or didn't come to my talk last time, totally fine. My name is Grace Jansen. I don't come from Sweden, although my name's kind of almost could be Scandinavian. It's Dutch, not Dutch either, it's confusing, just English, got a Dutch grandpa, speak no other languages, I'm afraid. So just English for the moment. So yeah, I come from the UK. I actually kind of took a rogue route into tech, so very much related to the keynote we had earlier this morning around sort of welcoming everyone into that community. So I did a biology degree before coming into technology. So sometimes my slides might be a little bit unorthodox, so bear with me with those. I like to bring in other references and analogies. But today, what I'm going to be focusing on is really around the open source cloud native Java space, which is where I primarily work in now as a developer advocate. And we're going to be taking a look at cloud native dev tools. So really, how do we enable effective development of applications, effective testing, etc., on our local machines whilst we're building cloud native applications that are going to be deployed and running in the cloud. So taking a look at sort of what tasks we need to do and what open source tools are available to be able to make use of to make that more effective for the cloud. So the first thing I want to ask, now my click is not working, we'll just go with that. First thing is sort of, I've got several questions that I'm aiming at here, really to introduce the topic and to introduce kind of why we're covering this, what we're covering, etc. So the first question is why? Why are we bothered about effectively creating cloud native applications and replicating that environment on our local machine? Why are we excited about the cloud? Now, hopefully there's some Disney fans in the room and you get this reference. And it's this, it's, ooh, the cloud. It's this excitement we get when we think about the cloud and what it offers. It offers many different benefits and advantages, things like innovation for applications, portability, flexibility, scalability, all of these benefits that we didn't necessarily have when we were using, say, proprietary on-prem solutions rather than cloud technologies. So we as developers get excited about bringing these benefits to our applications. We want to do that in a manner that's as effective as possible. However, it's not always like this. We don't always feel excited and that warm, fuzzy feeling when it comes to developing applications for the cloud. Sometimes, if you're a bit like me, and I would say a little bit overdramatic, which I think is fair to myself, you might feel like this when developing for the cloud. Oh, it's just so annoying. It's so frustrating. It takes such a long time. Things break all the time. Now, if you're a little bit less melodramatic than me, it might be a little bit more just like this. Just general frustration, you're kind of having a rough day, and a lot of the time it can be a real pain to be developing cloud-native applications. And that's why I wanted to focus this talk today on how we can bring some of the tools that you may or may not have heard of into your everyday life as a developer to really help with this feeling. So first, the next question after sort of the why are we focusing on this is, what do we need to solve when it comes to this problem? So what are we focusing on? What tasks do we need to be doing as developers that we need help with? So obviously, the majority of my talk here is focused on developers. Now, developers' roles have evolved and changed over time. So we don't just write and edit code now. We're also looking at things like the build part of our application lifecycle. We're in charge of creating effective tests for our application, and also moving more into sort of a DevOps role, as many teams are, looking at sort of deployment of our applications as well, and kind of being in charge of that a lot of the time. And in addition to that, we're looking at things like, we want coding assistance when we need it. We might not need it all the time, but it can be helpful. And we want to use our own IDEs, our own editors. I think it's safe to say we're quite an opinionated lot, and your favorite IDE might not be my favorite IDE, and I don't want to be forced to use the one that I don't like. So having that flexibility, having that choice, having that freedom. So putting this into sort of a diagrammatic format, just to make this a bit easier to follow through this presentation, what we do as developers looks a little bit like this. Now, you might have some additional arrows in there, you might have some additional phases, but I'm kind of generalizing here, hopefully to apply to everyone. So we've got kind of a create stage where we're initially creating our application, creating our code. We're looking at sort of, we got to build it at some stage. We might edit it a bit to add some new functionality, some new features, some new application logic. And of course, as all great developers, we're obviously following best practice. So we're testing regularly. So testing a lot of our application and then going through this cycle again and again and again until we eventually want to deploy somewhere and see it in reality. And a lot of this, as I mentioned, all happens within our IDE or editor. And the great thing is that there are tools and plugins and extensions that we can use, which means we can do it all in this one environment, which is some of the tools I'm going to be covering today and showcasing. So that's kind of the what are we focusing on. And I'm going to go through each of these phases of this development cycle and look at what tools we can use to help with this. So now on to the how. So how do we enable effective cloud native development? Now, one idea that people might have or you might think of is this notion of beam me up, take me to the cloud, I will develop there. And sometimes that can be effective. Sometimes it can be a real waste of time because it takes forever to be able to do anything. And it sometimes can just be a lot easier to do it on our local machines using cloud native technologies. So it's not always best to be going sort of up into the cloud itself. Another technique is sort of bringing that cloud back down to us. So bringing it into our local workstations so that we can still develop locally, but be ready for that cloud native production environment. And a lot of the technologies I'm going to be focusing on today take more of this style of approach of bringing the cloud down as opposed to taking you up into it. So this is what we're going to be focusing on today, hence the name of my talk. So in order to do that, there's several different open source Java frameworks and technologies that we can make use of. Many of these I'm going to be focusing on in the demo today. The clues are on my t-shirt with the logos I'm wearing. But essentially, these are all open source, and the nice thing about open source Java is it's all switchable. So if you don't want to use something like OpenLiberty, which I'm going to be showcasing, you can consider something like Wildfly or Quarkus or Payara, whatever it might be, because they all make use of the same or can interoperate with the same open source specifications I'm going to be mentioning. So that's, again, another benefit, portability, flexibility. So I mentioned OpenLiberty. So this is the cloud native runtime that we've been developing. It's open source, and yeah, it's what basically most of the demos are going to run on today that I'm going to show. As I said, though, you don't have to use this if you don't want to, but it is a really great tool to get started, especially because we've got some great guides that you can use that are free to take use of to try out these technologies. The OpenLiberty is it's modular, so you don't have to, you can basically pick the APIs that you care about. You can make it as small or as large as you want, which is obviously important when running in the cloud. And it interoperates with loads of different open source technologies and specifications. So one of those is microprofile. So hands up if you've come across microprofile. Nice, there's some hands up. Perfect, great. Okay, so it's about half I saw in the room there. Maybe you're just shy. But just in case you've not come across microprofile before, it is very much a community-driven specification that was designed to enable APIs to be introduced into the sort of Java environment to be able to enable us to create effective cloud-native and microservice-based applications. So it really added in this innovation that we desperately needed at the time that kind of the Java language wasn't quite able to keep up with. So it enables things like, for example, us to be able to have external configuration, which can be extremely helpful in cloud-native environments. Things like CDI injection, reactive messaging, open API documentation. So there's lots of different APIs here that you can make use of. And I definitely recommend, if you've not seen it before, checking out this specification in more detail. Now, as I mentioned, it's an open source specification, which means you need an implementation to be able to actually make use of it. But again, it's open source, so the choice is yours. There are lots of different implementations that you can make use of depending on your previous toolkit, what licenses you have available, or just which one you prefer, really. Again, we like to be opinionated, so pick the one you like. So in this, you can see there's lots of different versions of microprofile. We've just had 6, which is being released at the moment. So we have OpenLiberty is actually helping to release that as the compatible implementation, but lots of choice here if you'd like to check it out. The other one is Jakarta E. Sorry, did you want that? Go on, quickly. No worries. The slides will be available afterwards, so if there's any links that you don't quite catch, I will try and look out to see if people are taking pictures. But if there's anything you don't catch, just let me know and I'll go back or check out the slides after. Jakarta EE is another community-driven specification, again, also under the Eclipse Foundation, also open source. And this is really sort of the next evolution of Java EE. This was where it was open sourced, and it enables lots of different APIs, some of which are actually shared with MicroProfile. So that bottom triangle, I like to call this the MicroProfile pyramid. The bottom part of that is actually, a lot of them are shared with Jakarta EE. So things like JAX-RS, for example, CDI, for example, JSON-B, JSON-P. A lot of these are shared APIs between the two specifications. So there's quite a lot of kind of crossover between the two. In fact, the same individuals helped to develop both. So you'll see some similarities. So some of the specifications that enables, as you can see here, and there's different sort of platforms that you can use from it. You can use the core profile, the web profile, or the enterprise edition, depending on which APIs you need to be able to make use of. But again, lots of different implementations. If you head to the Jakarta EE website, you can find the compatible implementations there. So with these open source specs in mind, the reason I introduced them is because I'm going to make use of some of the sort of tools that are associated with them to be able to showcase that pulling the cloud back down and being iterative developers and sort of introducing it into this development cycle. So now we're going to go through each of these phases and check out some of the tools that are available. Now, the first few, create and build, I may be telling some of you to suck eggs. Please bear with me for some of them, because others in the audience may not have come across these before. And also, it's just good to revise and good to bear in mind that you guys, some of you guys in the audience may be senior developers with years of experience. There are junior developers on your team. Are you ensuring that they're aware of these tools, that they have them installed and they're able to utilize them? So bear with if you already know some of these tools. Some towards the end are sort of much newer and hopefully will also be of interest to you. So the first stage is the create stage. So this is really, how do we get started with an application? Now you might be thinking, oh, but I already have an application. I'm not a greenfield application. Well, what if you want to just try out a tool, for example, try out a technology? How do you easily spin up an application that's ready for the cloud to be able to test out those technologies? And starter projects can be a really great way to be able to really quickly and efficiently spin up cloud native applications on your local machine ready to go. So having that framework or the basic bones of an application. There are different ways that you can do it. So there's the MicroProfile starter project. So if you know that you want to use MicroProfile, then you can head down this route, and it allows you to select any of the compatible implementations that I mentioned earlier. You can either do that through the website, or you can have you can install essentially extensions or plugins into your IDE of choice. Currently, there's extensions for VS Code and IntelliJ. Sorry to the Eclipse fans out there, but hopefully you can at least try one of these. There's also other starter projects. For example, Jakarta EE has one. So if that's a specification you want to take use of, then head to the start.jakarta.ee website. Or there's runtime-specific starter projects. So if you already know the runtime you want to use, then you can just head to that website, and usually they'll have a starter project part of the website. So in Open Liberty, we have a starter project that you can make use of. And essentially what it allows you to do is you can use the website here to be able to really easily select drop-downs to just simply choose what version of Java you want to use, MicroProfile, Jakarta EE, for example, what the name of the project is going to be, those simple things, and essentially it will just very easily spin up a basic application for you. I'm going to show it in one of my demos later. It kind of builds onto another demo. So for everyone who's super excited about seeing this, hold your horses. It's coming in a bit later. So that's the create stage. So this is a really easy way to get started. You can get started in like 10 minutes. So super quick and effective. What about the build phase? So when it comes to building an application, as developers, it can be tedious to have to rebuild, repackage, redeploy applications every time we want to see a code change or we want to see the effects of that. So what tools are there available to make this easier? Well, dev mode is an excellent tool to be able to make use of. This is a Liberty feature, but there are lots of other alternative features that do similar things. So for example, in Quarkus, I believe it's Hot Reload, I think is the name. But as you can see, lots of different runtimes offer the same thing. essentially what this is a hot deploy tool. So what it does is it's able to start the server, watch for app changes, and then rebuild and repackage when it's needed and redeploy. So it does all this automatically in the background, taking the onus off you as developers to have to manage that and do it manually. So this can be really great to be able to see code changes immediately when you need to see what the effect of that code change is without having to tear down your application and start the whole thing again. The nice thing is there's also container support. So as many of our applications are actually being deployed into containers, it can be useful to be able to have dev mode running in a container to actually see how it would be responding in that environment. So there is container integration. Basically, the difference is really easy. It's on your right. Yes, right. So instead of running Maven, in this case, we're running Maven. I should point out for any, again, opinionated, if you prefer Gradle, that's totally fine. If you prefer Ant, that's totally fine. I'm just showing Maven in this example. You can use any of those tools. So in this, we've got Maven Liberty Dev. If you want to run it in containers, you just need to add the C on the end, and we have container integration already ready for you. And the nice thing about this is it also offers sort of debugging as well. We have a debug port that's automatically made available and allows you to connect to your IDE. So again, you never have to leave that environment, which is quite nice. Now, if your runtime doesn't offer this sort of hot deploy tool, don't panic. There are open source alternatives available if your runtime doesn't offer it sort of in-house. So there's a really cool project done by Adam Bean. You guys may be familiar with him, really active in the Java community, called Watch and Deploy, WAD. So essentially, it does a very similar thing. It watches for any changes that we make in the project, and it's able to redeploy our applications. So if you don't have that within the runtime you're using, this can be a really interesting project to check out if you did want a similar capability. I've also included, on most of my slides, I've tried to include a link. So if you're interested and want to follow up with these things, then you can check out the links that I've provided. Okay, what about the edit phase? So in this, we're usually in an IDE or an editor. So a lot of these are extensions and plugins and sort of integration with IDE to be able to make life easier as a developer when we're doing this. So one of which is sort of this is a very, you might think of this as quite a simple concept, but it's a very effective tool. If you're not making use of it, or if your junior developers don't know about it, then please make sure that they're aware that there are loads of extensions and plugins out there for lots of different IDEs, for everyone who didn't see their favorite IDE on the previous slides, that you can make use of to be able to make that a lot easier with the cloud native specifications you're using, like Microprofile and Jakarta E and the runtimes I mentioned. So I've got some examples here from Visual Studio Code, and essentially they help us to manage the lifetime of our application and that development. So it can be really, really convenient. Now I've shown here, I've got just a demo of just how easy it can be to install. This is, for example, in Visual Studio Code. I've tried to include an example from every IDE to make people happy, so hopefully your IDE is shown in one of my demos. But you can see here we've got things like tools for Microprofile and the starter project. We've also got Liberty tools installed within this as well. Liberty tools gives us the ability to be able to run specific Liberty features like dev mode, to be able to start and stop our server, to be able to debug, as I mentioned. And here you can see we're actually making use of the Microprofile starter project to be able to start up an application within our IDE rather than having to leave this tool at all. So we're basically configuring some basic configuration variables, like what version of Java we want to use, Microprofile, what APIs we want to have within our project, because again, it's modular. You don't have to have all of it. We're just making sure that we've got this in the right place. And then essentially, it's as simple as clicking a button, and you can see that started in literally a couple of minutes, and I've got the basic framework of an application there. So it can be a real time saver, especially when you're trying out new tools and technologies for the cloud, to be able to see whether they're useful, just to spin up an application like this to check it out. And you can see this is the dashboard that I mentioned, where you can see our REST client, for example. You can interact with that within this dashboard. That's part of the Liberty Tools extension I mentioned. So all of these plugins and extensions can really make your life easier as developers when you're developing cloud-native applications. And they can also offer things like sort of helpful hints and tips when it comes to the various configuration or variables within your application. So in this example, this is in Eclipse. So all my Eclipse fans out there, hopefully you're happy. So this is in the Eclipse IDE. And this is just a demo showing the Liberty config language server. So it basically enables you to have sort of useful information about the configuration variables you're making use of within your, in this case, it's a server.xml file. But the nice thing is, other things that you can make use of are like completion for Liberty properties and values, completion for variables, completion for XML configs, and this hover over function that I'm demoing here for Liberty properties and variables and for XML configs. And there's also diagnostics that you can gain from this as well. So this can be really helpful in terms of developing your application and editing that code. Okay, what about, I've kind of covered runtime specific stuff there, especially with the Liberty Tools extension I showed. What about specific help when it comes to coding assistance, specifically for the open source specifications I mentioned, MicroProfile and Jakarta EE? Well, we have some language servers that can help with this. So one of which is LSP for MP. We just love acronyms in tech, so why not make it a long one? This is the language server for MicroProfile. So essentially, this is an incubator project that's currently being developed, but there are some, so for this particular one, there is a Red Hat tool that you can make use of, an extension for VS Code specifically, that has been developed if you want to use it within the IDE. But this essentially gives sort of language features. It provides in-editor language features for MicroProfile API, so things like code completion or snippets for popular APIs, diagnostics, quick fixes if anything's incorrect. So it can be really helpful when you're developing your application, especially if you're new to these specifications, to get some sort of help whilst you're coding. Now, as I mentioned, you can use this within VS Code using that Red Hat extension. As well as MicroProfile, there's also another project for Jakarta EE. So really cleverly named LSP for Jakarta. Surprise. So this is for the Jakarta project. Again, another incubator project. So although these aren't sort of fully fledged projects, they're being actively developed. And we'd love your feedback. So if you want to give it a try and see if there's features missing, please let us know, because then we can build on it and make it better and hopefully make it more usable for you guys. Or if you want to contribute, please also contribute. We're always looking for more open source developers to help us build these. But essentially, again, this gives sort of in-editor language support. So I've got a brief demo just to show what this looks like. So this is in IntelliJ. So hopefully any IntelliJ fans out there. There's also an IntelliJ talk, I think, going on. So thanks for skipping that and joining mine. But yeah, so this is an IntelliJ, and this is showing the language support for MicroProfile. I'm also demoing this for everyone who was on the edge of their seat waiting for this demo, the dev mode from OpenLiberty. So that's also demoed within this demo as well. So in this, what we're doing is we're just creating a cafe controller class. And what we want to be using is the REST client annotation from the MicroProfile specification. But when we actually, I'll let this sort of run for a little bit. So in this, we're just creating this. You can see that I've got an error in my path there. So actually what I can do is look at the quick fix, and actually it's telling me I haven't imported it. So it can just offer me that quick fix really easily. Now, when I start using the @REST client annotation, now I'm immediately going into my application code here, but my issue, which you'll see in a minute, is that I need a CDI bean injection, which I haven't included yet. So this is a mistake on my part. But with that quick fix, it tells me actually what I needed was that @inject annotation and a few imports to be able to actually make use of it. So you can see just right away, we're getting these warning messages, these sort of almost on bird on the shoulder style advice to help us as we're coding with these cloud native specifications. So it can be super helpful. Now also with edit, something that we might want to do is code generation. So what about if we want to generate, say, snippets of code or generate boilerplate code? Are there tools to be able to help with this? And yes, there are. Great news. So there are code generators like OpenAPI tools, and there's actually a talk later. So if anyone wants to go into this in a bit more detail, Elias is giving a talk in A4 at 1 o'clock. So check that out if you are interested in going into this in deeper detail. But essentially, what it allows us to do is generate in this case, we're generating a MicroProfile REST client from OpenAPI documentation. So it saves a hell of a lot of time if you've already developed your REST service to be able to auto-generate that REST client as well. Now, you can do it either via the CLI if you want to, or, as I mentioned previously, there is also an extension for this. So there is an extension for VS Code if you want to stay in editor. Now, another thing we can also do is also generate JAX-RS stubs as well using OpenAPI tools. Now, I've also got a demo for this one. So this is, again, in IntelliJ. I'm pretty sure the remainder of my demos are in IntelliJ. Hopefully, I've shown enough variety in my IDEs here. But a lot of this is applicable to other IDEs as well. So in this, we're utilizing the microprofile REST client generator to be able to automatically create a REST client to our application. So in this, it's kind of a very simple application. We have our Hello Controller REST service, which was what we're going to be basing this REST client on. And as you can see here, we're utilizing that generator tool. This is the OpenAPI documentation that was generated from the REST service, which we're utilizing to be able to auto-generate this REST client. So what we're doing here is just essentially making sure that we're sort of in the right place, and we're utilizing this tool. Yep, I'm going to pause it because I feel like it's going way quicker than I can speak. So in this, essentially what it's generated is we've generated the API directory, and we've also generated the models directory. Within the models directory, we have this sort of drink class, which is implementing the sort of the part of that API document that was referring to that drink. So if I press play, I think we're now on this bit. Yep, so this is our drink class, which is just implementing what we had within that OpenAPI document. So the name of the drink, the cost of the drink. It's not a particularly complex application, which you can see in our schema here in our OpenAPI documentation that was generated. And then we also had the API class, which has things like our exception classes, the default API class. So basically, this is the bulk of what we need to get this working within this sort of for the whole REST client interface. We can also see we've got some endpoints there with the right post or get annotations depending on what we need for our REST service. So you can see this has happened really, really quickly, faster than I can speak. And we've actually, because we've had this running in dev mode, so it was already running before we generated this REST client, it's automatically picked up all of our changes using dev mode without us having to redeploy our application. It's already sort of worked that all out. We're just providing the base URI here to be able to make this actually work. And again, you can see source compile successful. So we're already auto-compiling all those changes without having to do anything within the terminal, which can be like way quicker when we're trying to test out any changes that we make. Okay, so hopefully that's shown you the benefits of using things like code generators in that edit phase. As I mentioned, we're all excellent developers. We love to test. We love it. So how do we test effectively when it comes to cloud-native applications? So obviously we have the usual suspects. We've got things like JUnit, Arquillian, whatever your choice of sort of unit testing is. We have these sort of tests that have been around for a while that most of us are probably making use of. But there are some new kids on the block. So we have things like test containers and microshed testing, which really utilize containers to be able to effectively test our applications as close to production as possible. Now, microshed testing is just an implementation of the test containers framework. It's what I'm going to use to show in the demo today, but you can use test containers as well if you want to go directly into that specification. In fact, there is also a talk on that at this conference. That's happening tomorrow with Oleg. So if you're interested more in test containers, then definitely check out his talk tomorrow, which you can find on the schedule. I don't have the room for that one, but I know it's happening tomorrow at 1. It's happening at 1 tomorrow. So what it basically enables is sort of, has anyone come across the 12-factor app methodology? Anyone familiar with that? Yeah, I've got some hands and some nods. So you guys are probably familiar with the factor dev prod parity. It's all about having this similarity in all of the backing services we're using, the environment we're creating across development and production, to be able to have sort of minimize the risk that we might have issues that arise in production that we weren't able to spot in development or in our testing environment. Has anyone come across the 15-factor app methodology? No, shaking heads. I should have given this talk. If you haven't come across it, I've got an article online that you can check out on IBM Developer. Just Google 15-factor app, Grace. I'll probably come up. There's sadly not that many females called Grace in tech, so there's not that many links that'll come up. So check that out. But basically, it iterates upon the 12-factor app methodology. So it expanded that dev prod parity to just be environmental parity. It's about whatever environment you're using, it should be as similar as possible across development, staging, QA, DevSecOps, production. They should all have that parity across all of them. And this is a way that we can enable that when we're testing on our local machines. So the way that test containers work is essentially running your app the same way that they would run in production in a container with connections to external, say, backing services, whether that's a database or a Kafka service, whatever it might be. It's able to replicate that production-style environment and enables you to have more effective integration tests. So this is kind of, again, one of those tools bringing the cloud back down for us. Now, there are lots of different compatible implementations of this. This is just to name a few, just to show that there is portability with this as well. So Room A2, I wrote it down. Room A2 is Oleg's talk, so go and check that out. But basically, it makes testing a lot easier for things like testing your data access for integration tests, application integration tests, UI or acceptance tests, and things like supporting. It also supports JUnit, Spock, so all of your unit tests as well. So I've got an example here, as I mentioned. Actually, I'm going to pause this. As I mentioned, it is using microshed testing, which is just an implementation of test containers. Now, this is actually the reason I'm showing it in here is because this is one of our Open Liberty guides. And the nice thing about these guides is that they're all using open source, so you should be able to easily make use of them. You can either run them locally, or we have a cloud, we have a browser environment, basically. It's kind of based loosely off Thea, and it basically enables you to try it all out without needing any prerequisites downloaded locally on your own machine, which if you're in something like security or banking, it's a great security plus because you don't need to download anything yourself. So that should be a great bonus as well. So this is using that online environment. So as I mentioned here, what I wanted to show in this demo is really how easy it can be to turn a normal unit test into a test container and how quickly you can go about doing that. So in this case, I'm doing it locally. So if you want to use the cloud native environment, you can. I'm just doing this on my local machine. We have all of these guides in GitHub in the open source. So if you want to check out the code themselves, feel free. I should pause here. For each of our guides, we also have a finish and a start directory. So finish is essentially, as the name suggests, what you should get to at the end of all the instructions. So it can be a really useful reference point if you get stuck during the lab at all, or if you just want to skip the lab, you just want to see what happens at the end. That's totally fine too. But we also have the start directory, which is where you'll start, which is where I'm going to CD into in a minute. And that's where you kind of follow the instructions on for each of our guides. So in this, what we're doing is I'm just going into my start directory, and you can see my directory sort of structure there. In this, we're using, again, Liberty Dev Mode. So again, we're just using Maven in this example, but if you want to use Gradle, you can. And I'm just starting that with Maven liberty:dev. In this case, I'm not starting it with that container support. I'm just starting the normal dev mode. And you can see it's fairly quick to get started. We know it's running when we see this message, Liberty is running in dev mode, that I'm highlighting here with the stars above it. So it's kind of quick to get started and you know when it's up and running. Another dev mode example there. And then the next thing we're going to do is just take a look at some of the tests that we have in our application already. Now, this is a pretty simple application. All this application does is really, it's basically got like a category of names and of people. They have names, they have ages. So in this, at the moment, we've only got one test. And actually, if you take a look at the code, it's not really doing anything. We're just running this for just now just to see if it runs. So what we're going to do is in these guides, we actually provide all of the code that you'll need to be able to sort of follow along with this guide. So we just provide it for you. So you just delete everything and replace everything with what we give you, basically. So in this, you can see we're including the annotations at microshed test, at container, and at test. So I'm going to pause there. The at microshed test annotation basically tells our application we want to use microshed testing for this. The at container annotation is essentially everything underneath it is any configuration we need for that particular container. And then you guys are familiar with at test. It's just any unit test that you want to be using within this particular sort of bunch of tests. So the next thing we're going to do is sort of, again, the instructions give some further information on that if you want to check them out. So to be able to test in dev mode, we just have to hit enter. So we just hit enter here. And as you can see, we have a container now that's been spun up to be able to run our tests inside. And the nice thing is our test is still passing, which is good because it means it's working both on our local environment and in that container environment. But now we actually need to kind of test our application with something. So we're actually going to, the next thing we're going to do is create a REST client. So the way that test containers works is it's kind of a black box style of testing. So you need something to be able to actually like poke the test, to actually kick off the test itself. And that's where we need this REST client. So we're utilizing a microprofile again here to be able to utilize a REST client to essentially actually use the test that we're running in this container environment because of the black box nature. So if we just go back, and again, we're just going to make sure that this is running correctly. Yep, we can see we've got one container running in parallel. And actually what we can see here is we're building that REST client to be able to kick off the tests themselves. So it's all working correctly at the moment. The next phase is actually adding in the logic for our test. So in this case, we're just going to start with a simple single test for just now, just checking that we can create a person ID within our application. So we're just going to add this logic into our application. So again, you can either just copy and paste in the code that you need if you want to do a spot the difference, or you can just copy in the whole class because we provided it there for you. So if you go back to our test, now we're actually testing our application. We've not just got a dummy test in there. So again, we've got our container starting, we've got our REST client starting, and our test passes, which is good. So we can create a person. But one test isn't really great when it comes to testing our application because there's other functionality there. So the next phase is adding in more tests into this particular class that we want to test all within this container. So we're just going to replace this, and now we've got 6 tests running in parallel within this container. And again, we'll go back to our terminal and just check that this is all working. When we hit enter, we can see that we still got the container, we still got the REST client, and this time we see that all 6 tests pass, which is great. Now you might be thinking, yeah, but I don't always want the same container configuration for every part of my application testing. Now this guide continues, just in the interest of time, I stopped the demo there just because I knew I only had like 50 minutes. If you want to continue with the guide and see how you can set up separate containers for different integration, that's also covered within the guide as well, and it goes into further detail as well. So check it out if you're interested and you want to learn more. There is more to it. That's kind of the easy part, but just to show you how quick it can be to get started, converting a normal test class into a test container, like utilizing test containers. So hopefully that demoed that for you guys. Again, an example of bringing that cloud back down. Okay, so for all of those who are still with me, thanks. So deployment, because we're now living in more of a DevOps world where a lot of the time developers are either wholly responsible or at least a little bit involved in this stage of sort of the application lifecycle. And for this, I was taking a look at a tool called build packs. So has anyone come across build packs before? Couple hands, yeah, thanks for interacting, appreciate it, you're still awake. So anyone who's not come across build packs, this is basically a solution so that you don't have to manage and build and create Docker files. So this provides a framework and a runtime support for applications, and it transforms your application source code into container images that are able to run on any cloud. So it was initiated back in 2018 by 2 main companies, so Pivotal and Heroku. Heroku actually originally created the 12-factor app methodology, so pretty involved in sort of this area. And essentially, this was about unifying the build pack ecosystem with this platform to build pack contract that was really well defined, and it incorporates all of the learnings they had from the different initiatives they'd already created around build packs. So it's all about embracing sort of modern container standards. So it includes things like the OCI image format, and it takes advantage of sort of the latest cloud-native capabilities like cross-repository blob mounting, image layer rebasing, utilizing Docker API v2 registries, all of this great stuff it enables and helps you to be able to take advantage of. When we start to compare it to other alternatives out there, you can start to see that actually there's many advantages to utilizing build packs. So we've got some other examples like Dockerfile that I mentioned, source to image from OpenShift, Jib, KO. It allows you, the main thing here is it allows you to create an application without the need for a Docker file and without the need for you to have to manage that Docker file. It also enables you to have things like advanced caching. So it has built-in caching to improve performance. It gives you, importantly, which often isn't considered when it comes to development, a bill of materials. Now, this is all around software security, and this is obviously something that I think we're all aware is something that's becoming more and more prevalent and important in everyday activities within development, especially after the Log4j and Log4Shell issues that we experienced. So yeah, it allows you to have that bill of materials, the SBOM support as well to give you insights into the content of the application image. And it allows things like reproducibility, auto detection, rebasing, like I mentioned. To make use of this, there's something called Paquito build packs. So they are an implementation of that cloud native build pack specification that I was mentioning earlier. And the nice thing is they're available in multiple languages. So if anyone in here codes in more than just Java, hopefully considering you guys are here, you're mostly Java. But if you code in anything else, like for example, .NET, Go, Node.js, Ruby, whatever it might be, this is a polyglot tool that you can make use of. And what it allows is it essentially sort of, it provides you with that build pack capability. We have a build pack for OpenLiberty, for example, which allows you to, it basically provides the OpenLiberty runtime to a workflow that produces that OCI image that you can then run anywhere you want. So the way that you can make use of it looks a little bit like this. So to get started, we've just used, in this case, the starter project. So this is just, you can find it on GitHub, or you can go to the starter project and select, like we showed at the beginning from the website, select which variables you want. And then we need to select a builder. So a builder is just an image that contains all the components necessary to execute a build. So it's normally made up of 3 different parts. You've got a set of build packs, which essentially provides your application's dependencies. You've got a stack, which provides the OS layer for your app image. And then you've got sort of a life cycle, which puts everything together in your final app image. So it kind of bundles that all together. So in this case, you can see here we're using builder :base. So we're using the base builder. It utilizes Ubuntu as the OS layer. But really, there's loads of different builders you can make use of. If you head to the build pack documentation, there's a whole page on that which explains the different builders that you can make use of. So all we need to do is select the builder and then build our application with any additional environmental variables we need to specify. So in this case, we're just specifying that we want to use things like Jakarta EE and the OpenJ9 build. So it's really up to you as to which environmental variables you want to specify. I've got some links, useful links here if you want to check them out later. But here is a brief demo. So in this case, we're using the starter application. It's a very basic application that collects system property information every 15 seconds and just stores that in a list that you can access through a /inventory endpoint. So in this, what we're going to do is we're going to essentially make use of the build pack. So you can see that actually I'm not providing any specific information on the fact that this is Liberty. It's actually picking that up from my pom.xml and server.xml information to be able to build my end image. All I'm specifying is the exact same command that I showed earlier. I'm specifying Jakarta EE and I'm specifying OpenJ9. So you can see that here. It's essentially the same command I showed earlier in that previous slide. When I hit enter, that should then start building for me, utilizing those build packs and that builder that we chose, which is the base image. So we can go and check out our server.xml. So you can see in here, I basically kind of let it know already what I want to use, my dependencies, what I'm making use of in terms of the APIs from the different specifications, and it is able to automatically pick all that up to be able to build my OCI image, which is really helpful. Basically what it does is it goes down and it pulls each individual images, and it will output a production-ready image. No configuration needed, just point it at the source code, essentially. So it can save you a lot of time in regards to not having to manage those Docker files, as an example. So now we should be able to see that we can run the application. We can see that our application is starting up. So yeah, you can see the various different layers that it's making use of there, depending on our specific application. So we can see that our application is running just by using that docker run command, and just check that it's up using the health. Yeah, so it looks all good. So now we can go to our endpoint that I mentioned just to check that this is all working correctly. And this is just the /properties endpoint that I mentioned, where you can see all of the system properties that our application's been collecting. Yep. So it's all up, ready to go, and all I needed to do was that one command. So it can be a really effective way to get up and running for a cloud-native application. Okay, we've also got telepresence. This is the last tool, I promise. I'm not going to overload you too much. So telepresence, I just thought this was a really interesting tool that kind of spanned the entire application lifecycle that I thought would be an interesting one to mention because it's one that I'm currently looking into that I'm trying to hopefully create a demo around. So there's no demo for this one yet, but watch this space. So what is telepresence? So telepresence really allows you to swap a pod running in Kubernetes with a service that's running locally. So again, bringing that cloud back down to your local machine. So all the requests to the pod in Kubernetes are essentially redirected to that local URL and port. This is actually a sandbox project within the Cloud Native Computing Foundation, and it allows this sort of very fast local development for your applications, for your microservices. So it accelerates this inner dev loop, which is kind of why I've made it this sort of top level tool that spans the entire dev loop I was talking about. And it helps with things like shifting your testing left and using existing workflows. Again, really easy to get started. I know it's kind of small. Sorry, I put it on this slide, but you can refer back to these later. But essentially, all you need to do is this telepresence swap deployment command that we have here. And I've included 2 demo applications and a blog that takes you through that if you did want to try it for yourself using something like the starter application. How does it work? So telepresence consists of 2 core architectural components, like 1 and 2 that I've listed on the diagram here. This is a diagram taken from the telepresence website. So we have the client side, so the CLI telepresence binary, and a Kubernetes cluster side, traffic manager and traffic agent. So utilizing this telepresence connect command, we essentially allows us to utilize the traffic manager to establish a 2-way proxy tunnel between your local development environment and your sort of cluster that's running in the cloud, wherever it might be. So now what that enables is it allows you to be able to access remote Kubernetes services as if they were running locally. So again, bringing that cloud back down. The second thing is if you run the telepresence intercept service name command, this triggers the traffic manager to install a traffic agent proxy container that essentially runs within the pods. You can see it here. It runs within the pods associated with the target services, and this allows you to route the remote traffic to your local dev machine for you to be able to develop and test. So again, really useful for things like debugging and seeing how that local service that you might have made a small change to would interact with that cluster environment as if it was production. So again, that dev prod parity, trying to get closer to testing in production. So yeah, really interesting tool that you might want to consider taking a look at. So with all of that information, I'm sorry, it was a bit of a bombardment, but hopefully it was helpful. If you did want to try this for yourself, if you're interested in any of the microprofile or Jakarta EE specs that I didn't cover in this session, if you are interested in trying out some of the guides that I did show, then you can head over to the OpenWT website /guides, and that's where you'll find all of those interactive elements that you can try out for yourself. And our cloud native environment looks a bit like this. So this is where you don't have to have any prerequisites on your local machine. You just get the instructions on the left, a terminal at the bottom, and your IDE on the right-hand side. So really great for sort of just trying something out, especially if you can't download locally. So a bit of a summary for you, just to wrap things up. So here is a simplistic diagram of everything I've covered within this presentation today and kind of where it all fits in terms of what's specific to microprofile, Jakarta EE, or what's runtime specific, and which stage in that development lifecycle it connects into in terms of creating, building, deploying, testing, editing, etc. And as if I hadn't given you enough homework throughout this presentation, because I'm exhausting you in the first session of Jfokus. There are many useful links if you did want to follow up on any of this information later. I'm not going to pause on them too long because you can always check out my slides afterwards. So this is one in terms of things like those extensions that I mentioned. And here is some extra information on things like the build packs, telepresence, and more on our OpenLiberty guides. And we also have a deep dive. So if you really want to spend like 2.5 hours of your day trying it out, then try the deep dive, which takes you through kind of end-to-end creating an application all the way through to deployment. So with that, I'm going to say thanks for sticking with me for the whole thing. I appreciate it. I think I'm short on time. Yeah. People are just stunned into silence. It's like, whoa, so much information. No question. I mean, if you guys do have questions, like I'm here for 2 days. This is my one talk. So if you guys want to catch me in the hallway track, as we like to call it, then please do. Thank you.